Welcome back again. Assalamu alaikum, and this is lecture number 20. From lecture number 19 we have started talking about the systems defined by linear constant coefficient differential and difference equations. In this lecture we continue the same topic, and we are going to talk about the complete solution of the difference and differential equation, and we also talk about natural response and the force response in this lecture. The complete solution consists of the homogeneous solution and the particular solution, and after determining these two, we determine the coefficients in the homogeneous solution. So the complete solution will be the homogeneous solution plus the particular solution, including the determination of the coefficients in the homogeneous solution. Okay, let's find the solution of the following equation. This is the equation, and we need to find the solution for this. So to find the solution for the this difference equation, we first need to find the homogeneous solution, then we find the particular solution, and then we find the coefficients, and which will result into the final solution. So let's find the homogeneous equation. So recall, for the homogeneous equation we need a characteristic equation. So characteristic equation for the discrete time case is, so this is the characteristic equation, and replacing y by yh and replacing input by 0, we get the following expression, right? Now in this case, because this is the first order equation, so n equals to 1, so that means when n equals to 1 we have a naught, right, r power capital N so we have putting the value. So because now this we can say that capital N basically equals to 1, so k is 0, at 0 we have a naught and n k is 0, so n minus 0 n, and n equals to 1, so that means 1, and then plus the second term will be a1 and r power, right, for the k running from 0 up to 1, so a naught r plus a1 r power 1 minus 1, so it will result into a naught is basically, if you compare with this equation, right, this is your a naught, so here a naught equals to 1, maybe you understand. The coefficient of this is 1 and the coefficient of this is minus 1 by 4, so a naught equals to 1, this is a 1, so a naught equals to 1, a1 equals to minus 1 by 4, so by putting here we get, and this should be equal to 0, so that means a1 is 1, so that means r plus a1 is minus 1 by 4, and r will be 1 minus 1 0, r power 0 is 1, so it says that means r equals to 1 by 4, so we get r equals to 1 by 4, so the homogeneous solution is, so generalized equation for homogeneous solution is so we find y of h n equals to c1 and r is 1 by 4, so c1 1 by 4 power n. So this is the homogeneous solution. Okay, the next step is to find the particular solution. So in particular solution, we assume that output is of the same type as the input. So the input is 1 by 2 power n u of n, so that means it will be something like let be represented by y of p, and we say y of p equals to 1 by 2 power n, okay, and u of n with a constant c. So replacing the value of y of p in the given equation, so we get c into, so we have found the particular solution and homogeneous solution. Particular solution is let's write first the homogeneous solution. So homogeneous solution is y of n, y of h n, and this is equal to c1 1 by 2 n, and the particular solution we just found is y of p equals to 2 into 1 by 2 power n. So the complete solution will be y of n, and y of n equals to particular solution plus the homogeneous solution. Or okay, so y of p plus y of h. I forgot to mention n here. So y of p n plus y of h n. Okay, so by putting value we find that it is ypn is 2 1 by 2 n plus c1 and 1 by 2 to the power n, and we say n is equal to or greater than 0. So this is y of n. Now we are going to find the value of the coefficient, which is unknown coefficient, that is c1. Once we find this one, then it will be the complete solution. So c1 can be obtained from the initial conditions given. So we can say that y of n, okay, we write it in recursive format, so it will be y of n equals to x of n plus 1 by 4 y of n minus 1. This is the original equation. I just wrote it in the recursive form. So we are given that y of 0 is not y of 0, y of minus 1 is equal to 8. Okay, so putting the value of y of minus 1 in this equation, we find this is equal to y of minus 1, n equals to 1 in fact, so that it will be x of minus 1 plus 1 by 4 y of minus 1 minus 1 minus 2. Okay, so actually because we are already on y of minus 1, so we are going to find y of 0. Okay, so y of 0 will be x of 0 plus 1 by 2, and this is 0, so it will be y of minus 1. So this is y of minus 1. So by putting values, y of 0 is basically 8, x of 0, you can easily know that x of n equals to 1 by 2. Okay, so when this 0 to power 0, so it will result into 1 plus 1 by 4, right? And y of 0 is how much? Y of minus 1 is given, which is 8. So that means 4 ones are 4 twos are, that means y of this is y of, it's not y of 0, in fact y of 0, so this is equal to 2 ones are 2, 2 plus 1 3, so that means y of 0 equals to 2. Okay, so by putting value of y of 0 in this equation, we can find the value of c1. So let's put it. So if I write it like this, I hope, okay, I write it here. Okay, so what I'm going to do is I'm going to put the value of y of 0. So y of 0 means y of 0 equals to x of 0 plus uh, c1 this is not x, in fact this is uh, 2, right? Okay, so let me correct it. So y of 0 equals to 2, which we have just calculated, and then anything power 0 is 1, 1 into 2 is 2 plus c1, so that means c1 equals to 0. Oh, actually this one is wrong. Okay, 2 plus 1 is 3, so I have written it mistakenly 2, so this is basically 3. So when this is 3, that means 2 comes here, so c1 equals to 1. So now we have the complete solution of this differential equation, and the complete solution is, you understand, the complete solution equals to the homogeneous solution plus the particular solution. So in homogeneous solution, we had one unknown, and we solved the value, or we found the value of that unknown using the initial condition, and we are given that y of minus 1 equals to 8. So the complete solution is, okay, the homogeneous solution is also mistakenly written as this. Actually the homogeneous solution is 1 by 4 here, right? So that means this is not 1 by 2, this is basically 1 by 4, so it will be 1 by 4. So when n is equal to or greater than 0. Or you can also write the step function with it. So here is another numerical example, and we have to find the complete response. Now the circuit shown in the figure here has differential equation equal to this one, and we have to find the complete response. We are given the R value equals to 1, C equals to 1, and initial condition is y of minus 0 equals to 2, and the input signal is x of t, u of input signal x of t equals to cos of t, u of t. So if we look at this one, if you recall the previous lecture, we have done the same example, right? So let's take with some different values of these, but the generalized the homogeneous equation or the homogeneous solution will have the same value because the input value is different, right, along with the initial conditions, but we have done the same example. So let's take the same values of the homogeneous we already found. So if you recall, or you can recheck with the lecture, that it was y of h t equals to c e power minus t over rc, and the units are volts, right? So if I replace the values of the resistor and capacitor, so simply I get y of ht equals to c into, this will be exponentially taking signal, this one, and the particular solution is, which is also we have done in the previous lecture. So I'll just write down straight away the values of the particular solution what we found. So if you recall, or you can just check, so it's 1 over 1 plus RC omega naught square into cos of, so here omega naught is 1, so if I straight away replace with 1, right, because it was there. If I, so the input there was uh, cos omega naught t, whereas now we have cos omega cos of t and u of t, right? So if I compare the two, I can find that basically omega naught is now omega naught equals to 1, right? So that means I can erase this one, so I just replace omega naught with 1, so I'll get something like R C, right, square into cos of t plus RC over 1 plus RC square into sine of t, right? and t is greater than 0 because we have the step function here, and also R and C are 1, so that means we can say the particular solution we have already found is given by this 1, so 1 plus 1, 1 by 2, so I can straight away write 1 by 2 cos of t, right, plus 1 by 2 sine of t, where t is greater than 0. And the particular solution we obtain is this one, the homogeneous solution, right? So that means the complete solution will be equal to something like y of t, it will be something like y of t, and it is equal to, you know, complete solution plus the homogeneous solution. So homogeneous solution is c e power minus t and plus 1 by 2 cos of t plus 1 by 2 sine of t, where t is greater than 0. So now we need to find the value of this constant c. So we found on the previous slide. So let's put the initial condition, that is y of 0, by replacing t with 0. So that means c e power 0 plus 1 by 2 cos of 0 plus 1 by 2 sine of 0. So you understand that sine of 0 basically equals to 0, cos of 0 equals to 1. This will also result into 1, and y of 0 is 2. So we can say 2 equals to c plus 1 by 2. So that means c equals to, I think you can write 2 minus 1 by 2. So this results into 3 by 2. So the complete solution of this equation is given by y of t equals to c is 3 by 2, so 3 by 2 and e power minus t plus 1 by 2 cos of t plus 1 by 2 sine of t, and this is valid for t is greater than 0. So that's all for the complete solution of the difference and differential equations. It is informative to express the output of a system described by differential or difference equation as sum of two components and these components, one of them is the one which is associated only with the initial conditions. The other is due to only the input signal. We will call the component of the output associated with the initial conditions as the natural response of the system, and the other component of the output due only to the input as the force response of the system. So the complete output will be equal to summation of the natural response and the force response. Natural response, it is the output of the system when the input is 0. It describes the manner in which the system dissipates energy or the memory of the past presented by non-zero initial conditions. It is obtained from the homogeneous solution as it assumes zero input. And it is obtained by choosing the coefficients of homogeneous solution by satisfying the initial condition. So it does not involve the particular solution. You understand why? Because particular solution considers the input. So here we have the same example we have previously encountered two times. Once when we were finding the particular and the homogeneous solutions, and now particular and homogeneous solutions, and now the third time for the finding natural response. So the conditions are again similar. The involved resistance and capacitance are units, and we have x of t as input and y of t as the output, right? So we use the same expression that we have found the homogeneous solution in the previous lecture. Now to obtain the natural response, we'll choose C1 so that initial condition is satisfied. So let's write the already derived expression for the homogeneous equation solution. So let's see, if you recall or you have the lecture, you can see that the expression for homogeneous solution is y of ht equals to c1 e power minus t. You understand we have replaced the values of c1 and r1 so that the expression results into this, and you understand the output y of t is basically voltage, so y ht is also voltage. Now replacing value for the initial condition, you know that we represent the natural response by y of n. So this y of nt means the natural response of the system, and this is can be found by replacing values in the homogeneous solution, because we have already done this. So y of n0 is given, so we just replace y of n0 equals to 2, so that means c1 into e power minus 0. So y of n0, which is given here, this is y of n0, right? So y of n0 equals to 2, so replacing 2, I think these are quite straightforward, right? And this is your c1 e power 0 equals to 1. So the natural response is just simply y of n t, right? I hope you will not get confused with the n for the discrete time case, right? here it's just a subscript. So we find that the natural response is less 1 for those given conditions, right? And this 40 is equal to or greater than 0. So this is the natural response. Let's take another example using the discrete time systems. So let's we have y of n minus 1 by 4. By this example we have already considered while doing the particular and homogeneous solution. And minus 1 again, I think when you doing the complete solution. So this is equal to x of n. This is given. So you know, for natural response we replace the input with 0. So we can say that this is synonymous to what we do for the homogeneous solution. So let's find the natural response for the system. So if you can recall, we have done this before. So for the case of the homogeneous solution, it was y of h n, and it's equal to c1 and 1 by 4 to the power n. Now to find the natural response, we need the initial condition. So for example, the initial condition is y of minus 1. Let's use the same value we previously used for finding the complete solution. So we say y of minus 1 equals to 8. So that's quite straightforward to find the value for the natural response. So by replacing value in the equation we have obtained for the homogeneous, this is equal to, for example, minus 1, right? This is the homogeneous solution. Okay, so minus 1, this is equal to c1, and this is equal to 1 by 4 power minus 1. So this is equal to 8. So this will be equal to this 1 by 4. So power minus 1 means 4. So this is equal to 4c1. So that means c1 basically equals to 8 divided by 4, which results into 2. So the natural response represented by yn, and here we write the n. This is equal to, just replacing the coefficient value in the homogeneous solution, we get the natural response. So this will be equal to 2 into 1 by 4 power n. So this is the right, and this is valid for n is equal to or greater than minus 1. You know that the complete output is equal to the natural response of the system and plus forced response of the system. So we have talked about the natural response, and now we are going to talk about the force response. We have done some of the numericals using both discrete and continuous time examples to clear the concept of natural response. Now we are going to do the force response. Force response is defined as the output of the system due to input signal. So it assumes zero initial conditions. Thus, it is of the same form as the complete solution of difference or differential equation. A system with zero initial condition is said to be at rest. So the force response depends on particular solution, which is valid only for t is greater than 0 or n is equal to or greater than 0. So let's consider some of the examples using discrete and continuous time. Let's consider a numerical example to find the force response. So this example we have already done for the complete solution. Now let's redo it for finding the force response. The complete solution of this equation was y of n So this was the equation for the complete solution. Now to obtain C1, we translate the rest condition, that is y of -1 equals to 0 to n equals to 0. So we obtain y of 0 equals to, so we obtain y of 0 equals to 1 plus 1 by 4. You understand how I get 1? If I replace 0 here, so it will be 2 power 0 is 1, 1 by 1 into the 1, it will result into 1, and y of minus 1 is 0, so I get 1 here. So now using y of 0 equals to 1, so I can find the solution. Y of 0 plus y of 0 equals to, so replacing the value here, so I just put y of 0, so this will become y of 0 and this will become this. So I hope you understand. This will give you y of 0 is basically, we have already found 1, so it will be 2 plus C1. So it implies that 2 is added here. If I shift to the other side, it will be C1 equals to minus 1. So the force response can be found by, force response we understand is represented by y of f into n, and this is equal to x of n, and x of n is basically 1 by so putting values here, y of n will become y of n because we are talking about the force response. So replacing values here, C1 we found is -1, so we get this one as the force response. And you understand this expression is valid for n is equal to or greater than 0, and for other values of the n it will be 0. So with this we end the lecture for today. So these are some of the numerical problems. I want you to go through them. These are practice problems, so they will enhance your um, understanding and concept. So these the problem on this are related to the complete solution, whereas here the problems that are related to the natural response, and finally these problems are related to the forced response. So we have covered three topics in this lecture. One was the complete response, complete solution, then we determined the force natural response, and after that we determined the forced response. So these are the three different topics we covered. So the last three slides, they contain the numerical problems or practice problems. So hope you all of you will try them, and if you have any confusion we can discuss them in the live session. So that's all for today. Assalamu alaikum.